Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today I've got Kanrawee who has just completed the course Linux Basics for Robotics and she'll be giving us a presentation on that. So what I'm going to do is to hand over the platform to her so she can begin her presentation. Alright, whenever you're ready.
Okay, so first of all, thank you for having me here to present my work
Sure.
on Linux for robotics. So first let me launch the starting programs.
I suggest you close the window and open it again. You will be able to connect. Yeah, so you just open it one more time and you can click connect now.
Okay. So I'm just gonna launch the start programs.
Okay. So you can explain to us what you're doing.
Oh, okay. So here this one on this terminal is the robotics interface, and on this terminal is the robotics obstacle avoider. So this is gonna be the the program that's gonna help avoid the obstacles. And last, I'm going to be opening the robotics statistics program. And this program is going to be telling like the statistics about like the robots, so like distance covered, current directions, position, and orientation, as well as the velocities.
Okay.
Yeah. So here, as you can see, the robot is moving, and I programmed this robot so that like it has an emergency stop when it gets too close to the obstacle.
And how close is too close?
0.2.
Okay. All right.
So like just in case if it cannot detect or like if it goes too close to the obstacle.
Right now, okay, let's see. It seems to be struggling to. Okay, maybe it's
Yeah.
working. And can you, while we're watching this, can you tell us a bit more how it calculates the distance to move?
So how it calculates the distance? You mean like the distance for the threshold?
Not necessarily. So, okay, here's what's going on, right? Did you see that it crashed in that instance?
Yeah.
Yes, so what do you think is going on there? Is your safety measure failing or what's going on?
Oh, okay. So basically I set two thresholds. The
And
first one is
all right,
why is it crashing?
let's stop execution and maybe we can have a look at the code
Okay.
one more time. because I've seen it crash several times, so I want to know what's going on there. If you said you had a set distance to stop it within zero point 0.2 meters, why is it failing to do that?
Okay, let me open it up.
Um, is the off-to-go avoider script still running? Can you check in terminal 1?
Uh,
No. Okay, terminate that script and let's see. All right. Okay, so
okay, so
all right. So let's go to the code, right? Because I want to understand what did you do, and you explain to me why you think it's failing, and what could you have done better.
okay.
Okay, let's maximize that.
So
So let's get the terminal
yeah,
to be full screen, yeah. I just click the green button on the top left. You should be able to,
okay.
yeah, okay. All right, so take me through your obstacle avoidance algorithm. That's the one that I want to know.
Okay, the algorithm.
Yes.
Go down. Okay, so first, uh, okay, so first over here, I set two threshold. As you can see, the first threshold is 0.5,
Mm-hmm.
and the second one is like an emergency threshold,
Mm-hmm.
which is 0.2. So the purpose I set two thresholds was so that when when the robot moves, like when the robot moves and it's going too close to, if it couldn't detect on the first time and it gets too close to the obstacle,
Mm-hmm.
it would detect that it's getting too close and it would like move backwards so that it can have some space between the robot and the um
Mm-hmm. Okay.
and so yeah, so initially I just set it the speed to 0, and then here I got all of the 5 scans from the sensors of the robot. Um, okay, and over here it's uh wait, sorry. Okay, yeah, so over here is like where I wrote the emergency thresholds code. So what happens is that like if any frontal distance is lesser than the emergency threshold, which is 0.2 meters, it's going to back up. So over here, like I wrote like the frontal range is like if it's smaller than the emergency threshold, it's going to like and if the front right range is also smaller than emergency threshold, uh then the it's gonna stop and it's gonna like I said the linear velocity to be negative so that it would like move backwards and away from the obstacle. Okay, and then this one is so next is if the front range wait sorry if the left range is bigger than the right range, so that means that there's like more space on the left side, uh then it would turn left. So the angular velocity would be negative 0.8. So like how I calculated was just seeing on which side had more space. Okay. Um, and next is so I separated it into like 8 cases. So like for cases like where all frontals are blocked,
Mm-hmm.
and so if all the front side are blocked, so see, like front left range is smaller than threshold, and the front range is also smaller than threshold, and the front right range is also smaller than threshold, then it indicates that all of them are blocked, and uh, it would be turning to the clear side, which is it's gonna be like it's gonna calculate whether like left or right side is uh is bigger, and if like the distance on the left side is bigger, then it go left, and if the distance on the right side is bigger, then like it move right.
Okay, so right. From the way you're
Yeah,
explaining, the logic sounds correct, right? The only thing that I have an issue with right now is that what you're saying is not what the robot is exhibiting, right? So, did you test
yeah.
this algorithm? How many times did you test? Did you see it work? Do you have a recording of it working? Because from what I can see
Uh,
right now, it's not doing what you're saying.
yeah. When I tested it before, it worked well and it was avoiding the obstacle, but I'm not sure why today it was crashing a lot.
Okay, so let's give it another shot, right? So let's go
Okay,
back to the window and re-execute everything, and then let's see if it works.
okay. Okay, so I just launched the obstacle avoider program again.
Mm-hmm. See, that is the first turtle sign. Now, that's the first thing that I'm looking at right now.
Yeah,
It was facing the wall dead on, right? If your algorithm was
yeah.
working the way you're saying, it's supposed to stop in time. What linear velocities are you using?
Uh, let me check.
Okay, you can stop the obstacle avoider right now because it's not really doing what we want. Also, can you kill the robot interface .py? All right, so let's go to that other one.
Okay.
Right, so what linear velocities are you using? I can see there's zero point 0.1 in one instance, and there's negative zero point 0.1. Okay, so you have not used any linear velocity above zero point 0.1, correct?
Yes.
Yes, so it must be able to avoid that, or at least stop if your algorithm works correctly. But right now, it is not doing that. So unfortunately, we won't be able to look at this as a success. All right.
Okay.
All right. So you hang around and we wrap our conversation here. Okay.
Okay.
All right.
Thank
All right, everyone. This was Kenry's presentation, and I'd like to encourage all those of you who would want to try this course as well to do so. And then you can also come and showcase your work